Hello, this is the luckiest maths teacher in the world, and today we're looking at similar figures. Now, you would have done a bit of work on similar triangles, but actually you can have similar figures for any shapes. So two shapes are similar figures if one shape is just an enlargement of the other. So they're basically the same shape, one is just bigger. So this shape and this shape, they are similar figures. The second one's just an enlargement of the first. This shape and this shape here, they are similar figures. The second one is just an enlargement of the first. When they're not similar figures is if they are not just an enlargement of the other. So just because two things are the same shape, it doesn't necessarily mean they'll be similar figures. So for example, this triangle that I draw here is not a similar figure to this triangle. They're both triangles, of course, but they're sort of like different shapes. They have a different arrangement of their sides. So these two are not similar figures, even though they're both triangles. So sometimes you'll have quadrilaterals, so like a trapezium like this, that's not a similar figure with a rectangle, because I haven't just enlarged the rectangle the same in every direction. Think of it like if you were to put a shape on a computer and then you were going to get the computer to stretch it out. I can't take this shape, this rectangle here, and stretch it in a way that will make this shape here. I've done different things to different sides. I've moved this side like over here, this side over here, and I haven't really done much to these sides here. So, similar figures are just one stretching of the other. So let's look at a more formal definition. So two figures are similar figures if they have exactly the same angles and all sides are in the same proportion. So what I mean by all sides are in the same proportion, like, the second shape, all its sides are, say, double the length of the first shape, or all its sides are triple the length of the corresponding sides in the first shape, and so on. So both of these need to be true. So let's look at some examples. So are these two shapes here similar? Well, intuitively, they're not, because one's a rectangle and one's a parallelogram. They're not the same shape. But let's go ahead and look if either of these conditions is true. So do they have exactly the same angles? Well, a rectangle has all four angles equal to 90 degrees. Now this parallelogram here, clearly each angle isn't 90 degrees. You can tell that just by looking at it. So we could measure the angles as well just to be sure. So they don't have exactly the same angles, therefore they cannot be similar. Interestingly though, I've set it up so the sides are in proportion. So what I mean by in proportion, so if I divide this side by this side, so 10.5 divided by its corresponding side, and then this side and this side are corresponding, they give you the same answer. 10.5 divided by 7 is the same as 9 over 6. And of course this side divided by its corresponding side is 9 divided 6. 10.5 divided by 7. So if I take a side in this shape here and I divide it by its corresponding side in this shape here, I always get the same number, 10.5 over 7 or 9 over 6, which is equal to 1.5. So actually in this example all sides are in proportion, but the shapes are still not similar because they don't have exactly the same angles. Two shapes need to have both of these to be similar. So these two shapes are not similar. Even though sides are in proportion, they don't have exactly the same angles. Let's look at another example. So, are these two shapes similar? Well, we don't know anything about the angles, so we'd have to measure the angles if we wanted to see whether or not they had the same angles. But let's first check about the proportion of their sides. So if I take a side in this triangle and divide it by a side in the other triangle, its corresponding side, I should get the same answer. So 15 divided by 12. Now if you put that on your calculator, you get 1.25. But if I divide this side by its corresponding side, 12 divided by 8 is 1.5. I didn't get the same answer here as here. So the sides are not in proportion. So I really don't need to know anything about the angles. I don't need to measure them. I know that the sides are not in proportion. Therefore, once again, these two shapes are not similar. To be similar, they need to have all sides in proportion and all angles equal. So now we're going to go ahead and look at the concept of a scale factor. So I've given you an explanation of what a scale factor is. So we know that if two figures are similar, all sides are in proportion. So proportion means when you take one side of one shape and you divide it by its corresponding side in the other shape. That number is the scale factor. So let's look at an example to make this clearer. So let's say I had two shapes like this. Either you found out that they're similar, or you're told that they're similar. The scale factor is just what I need to times by the length in one shape to get the length in the other. So if I call this A and this B, the scale factor from A to B is just what I need to times by this length to get the length of the corresponding side in the second shape. So it's just 30 divided by 6, which is 5. Now the scale factor, if I want to go from B to A, that would be what do I need to times by this to get that. And it's just the opposite. I need to divide by 5 or times by 1/5. So the scale factor of the first one is 5 over 1 from A to B. The scale factor of B to A, you just flip the fraction. So let's look at the two shapes in black. So I'm telling you that they're similar. So let's go ahead and figure out the scale factor. Now when you're figuring out the scale factor, you have to make sure that you know which side corresponds with which. So this side and this side are corresponding. If you like, I've enlarged this side to get this side here. It's important that they line up. The scale factor is what I need to times by 12 to get 30, not what I need to times by 12 to get this one here, because this side is not a corresponding side to this side here. So make sure you pick corresponding sides. So the scale factor is just 30 divided by 12. This is the scale factor from A to B, and that, you can simplify it on your calculator if you want, is 5 over 2. So the scale factor from B to A will be the opposite. I'll just flip the fraction over, it'll be 2 over 5. So that means that if I times 12.5 by 2 over 5, I should get this side here, because this side and this side are corresponding. So it's important that you understand scale factors, because they will come up for the next few lessons. Hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.